everyone! In our last video, we learned the basics of exception handling using a single try-catch block. Today we are going to go deeper and learn how to handle multiple different types of exceptions using multiple catch blocks. Multiple catch blocks. Let me start with a real scenario. Imagine you have a try block with multiple critical statements, and each statement could do a completely different type of exception. For example, one statement might cause an arithmetic exception. Arithmetic exception. For example, dividing a number by 0, another statement might cause an array index out of bounds exception, like accessing an array at an invalid index. If you use just one catch block with the generate exception type, you can handle both, but you lose the ability to respond to each exception specifically and meaningfully. So multiple catch blocks solve this problem, and each one handles a specific type of exception with its own specific response. Let's see this with a real example. We have a variable named num equal 4 semicolon, and we also have an array named r with 3 elements, 10, 20, and 30. First, I write my try block, then the catch block. Inside the try block, I write the critical statements first and result equal 40 divided by num, semicolon, and I want to print result concatenation, the name of the variable result. Inside the catch, I write the name of the class. So if you remember in the previous lesson video, we said that inside this one we write first the name of the class, which is for the arithmetic operation, it is arithmetic exception, i.e. the object. And when there is an error with this critical statement, I want to print this message: arithmetic error accurate. And I also want to print the message, so I write the name of the object AE. So this one is for this critical statement, right? What if we also have another statement? And another statement is like I want to print an element from my array R with index of result. Whatever the result is, I want that element be printed. For example, if the result is 0, this element should be printed. If it is 2, this element, and 2, this element should be printed. Now what if the result is something like 3, 4, 5, 10, 6, 7. For example, 40 divided by 4 is 10. But we don't have an element in this array with index 10. So we have a critical statement here, and let's write for that a catch block, because this one belongs to arithmetic exception. Now let's write a catch block for the array. For the array, we have a class name array index out of bounds exception, and the object. And when this exception happens, I want this message be printed: array index error accurate. And the message also want to be printed plus AIO. So we already have the number let's run the program. It means 40 divided by 4. We see for the first statement we have 10. There is nothing wrong with that, but when we want to print the element with index 10, we have an exception here, which is array index error occurred. Our message is printed and then the message is shown. It says index 10 out of bounds for length 3. Now let's see what will happen if we change the number of num to 0. Let me run the program. And here we see that this time the first catch block is executed and it says that arithmetic error occurred and the message is by 0. So this is the power of multiple each blocks. Different exceptions get different specific responses and handles it specifically. Before we talk about the ordering rule, you need to understand something about how exceptions are organized in Java. All exceptions in Java inherit from the exception class, which is the parent of all exceptions. So arithmetic exception class in here is child of exception class. And this class, ArrayIndexOutOfBoundsException, is also a child of exception. This means if you catch exception, you catch everything, including arithmetic exception and ArrayIndexOutOfBoundsException, because they are all child or subclasses of exception. And this leads us to one of the most important rules about multiple catch blocks. So, always the child exceptions catch before parent exceptions. Let's see what happens when we violate this rule. Imagine we have another integer named a equal 10 and an array r with the same name as previous one with the same elements 10, 20, and 30. I write from the beginning to make our example clear. Again, I write the try block, and then I write the catch block. So, for the try block, I write our critical statement and b equal 3, for example, divided by a. And I want to print array of one element from the array of r with index of b. And for the exception, for the catch, I want to use the exception class, which is the parent class and catches everything. And I want to print parent exception caught. And now another block I specify it for the arithmetic. For arithmetic class, arithmetic exception. Let me see if there is not any error. Arithmetic. Yeah, everything is fine now. And here I want to write arithmetic exception caught. And this is the child, right? But unfortunately, it never reached to this one. I don't know if it is unfortunately or not. So let's read the message here. Error say exception include main java.lang error and resolve compilation problem. Unreachable catch block for arithmetic exception. It is already handled by the catch block for exception. Java immediately gives us a compile error which says this. Why? Because exception, the parent class, already catches everything, including arithmetic exception. So the arithmetic exception catch block can never be reached and it is unreachable code, and Java does not allow that. Now let's fix this. Let Java goes from child to the parent. Let me just cut this one, bring it at the bottom. Look, immediately the problem is solved and there is not any error. Now let me run the program. Now we don't have any error in the compile or in the console, right? And you can also add another catch block here. Catch. And this one is array index out of bounds exception. And in here we write this message that array index exception cut. Let's run the program. Let's add this one as 30 and add this one. Okay, when we divide 30 by 10, we have 3. And in here we don't have an element with index 3. And here array index exception cut, right? You can also try for 0 for an arithmetic error. An arithmetic exception cut. So now you can see the code compiles and works perfectly, and Java checks each catch block from top to bottom and executes the first one that matches. Having the parent at the bottom ensures that specific exceptions are handled first, and the parent only catches anything unexpected that was not specifically handled. So it can be always added at the end of this catch blocks. So that is try with multiple catch in Java. If you enjoy watching this video, make sure to like and subscribe the channel so you never miss a video. See you in the next one.